Today we're going to be talking about section 8.3, which is on graphing general rational functions. And our goal is to graph a rational function with higher degree polynomials. So what we're going to do is we're going to take everything that we learned in section 8.2 about these functions, and we're going to apply it to a general function rather than just the hyperbolas that we talked about. So when we graph the rational functions, we're going to let p of x and q of x be polynomials with no factors other than 1 or -1 in common. And then the graph of the following rational functions has the characteristics listed below. That f of x is going to be p of x over q of x. Now this function is going to have the following characteristics. We know that the x-intercepts of the graph are the real zeros of p of x. Now notice p of x is here. So to find the zeros, we're just going to let p of x equal 0. And then we're going to solve it. Okay? So that's how we get the zeros of the function, or the x-intercepts. Number 2, it says the graph of f has vertical asymptotes at each real zero of q of x, and q of x is in the denominator. So then once again, just like we did the other day, we're going to set q of x equal to 0. That gives us our vertical asymptotes, which is the restrictions that we have on our domain. And the difference here when we graph these polynomial functions now comes when we talk about the horizontal asymptotes. The horizontal asymptotes are determined 3 different ways. You have 3 different situations. First of all, here is the degrees that we're going to be talking about, m and n. If we have a smaller degree in the numerator than we do in the denominator, then we have a horizontal asymptote at y equals 0. For example, if this is an x squared in the numerator and an x cubed in the denominator, our horizontal asymptote would be y equals 0. The next situation we would have is if they are the same. Well, we've already talked about that one. That's what we looked at the other day. And that comes from dividing the lead coefficients. The lead coefficient in the numerator divided by the lead coefficient in the denominator. That would be our horizontal asymptote in that situation. And the third one is what happens if the degree in the numerator is now higher than the degree in the denominator. And when we do that, there's going to be no horizontal asymptote. So those are the 3 situations with our horizontal asymptotes. So again, we can set the numerator equal to 0, that finds our x-intercepts. Set the denominator equal to 0, that finds our vertical asymptotes. And then look at the degrees of each of those functions in the numerator and the denominator. If the degree in the numerator is smaller, y equals 0 is your horizontal asymptote. If the degrees are the same, then you divide the leading coefficients. That's your horizontal asymptote. And if the degree in the denominator is bigger, then you don't have a horizontal asymptote. So let's look at example 1. All right, so let's do those 3 things. First of all, set the numerator equal to 0. Well, that's never going to be true. So therefore, there are no zeros, no x-intercepts. It won't cross our graph anywhere. Let's set the denominator equal to 0. We're going to get x squared equals -2. I'll have to take the square root of that. I can't take the square root of a negative number. It's imaginary, which means there are also going to be no vertical asymptotes. Okay? So now we have to look at the degrees. The degree in the numerator is 0. The degree in the denominator is 2. So 0 is less than 2. So we're in this situation, which means y equals 0 is our horizontal asymptote. And now what we have to do is plug in some points. So if we put in 0, we're going to get negative 1. If we put in 1, well, 1 squared is 1 plus 2 is 3. We're going to get negative 2/3. If we put in negative 1, we're also going to get negative 2/3. If we put in 2, now that's 4 plus 2 is 6. So we're going to get negative 2/6, which is negative 1/3. And we'll see what's going to happen here is this graph is going to get closer and closer to that line, that horizontal asymptote, but it will never touch it. And there is our graph. Now we need to look at what is the domain and the range. Well, remember, our domain is our x values. What values can we have for x? So in this case, we look at goes forever in the right, forever to the left. So our x values in our domain is going to be all real numbers. There are no restrictions on our x values. Now if we look at the range are y values up and down. Well, we know that everywhere on our graph is not going to be a solution in this case. It cannot, you don't see any blue above that graph, and we won't. Also, it only goes down to 1, and when it gets to 1, it turns back and goes back up. So we have a very small range in this case. The smallest value is negative 1, and it does equal negative 1, and then it goes up to 0, but it does not touch 0. So it's going to be negative 1 is less than or equal to y, which is less than 0. So in this case, our range is restricted between those values. So let's jump down to example 2. We're going to graph this rational function. All right, and we're going to do the same thing. First, let's set the numerator equal to 0. Negative x squared equals 0. So we're going to get x squared equals 0, so x equals plus or minus 0. There is my x-intercept. Step 2, we're going to set the denominator equal to 0. This is going to find our vertical asymptotes. So in this case, we're going to have x squared minus 4 equals 0. If we solve it, well, you could do it one of two ways. You could factor it. You could solve it to different squares. This is going to be x squared equals 4. So x equals plus or minus 2, which tells me I'm going to have horizontal asymptote at 2, or sorry, vertical asymptote at 2, horizontal asymptote at negative 2. All right, so we found our vertical asymptotes. We found our zeros. Next, we're going to find the horizontal asymptote. Now notice here we have a degree 2 and a degree 2. They are the same, so we're going to divide the leading coefficients. Well, in this case, it's y equals negative 1 is our lead coefficient in the top, in the numerator. 1 is our lead coefficient in the denominator. So our horizontal asymptote is going to be y equals negative 1. So if we put that on here, there is our horizontal asymptote. And so now if you look at this, we're going to have 3 parts of our graph. Well, it's split into sections, so we have to plug in points in each of those 3 sections. So if we go to, let's put in 3, because we'll take this right side first. Well, we're going to get 3 squared is 9, so it's going to be negative 9. 3 squared is 9. Minus 4 is 5. So negative 9/5. So that's negative 1 and 4/5. So we're going to be right here. Well, we know that it's not going to cross the vertical asymptote. We know it's not going to cross the horizontal asymptote. So this graph is going to go like this. So we can also put in negative 3, go to the left side. And that's going to give us the same thing. We're going to get negative 9/5 because they're both squared. So that is going to be negative 1 1/5, and so, or sorry, negative 1 4/5. And so this graph is going to look like this. And we see that we have an x-intercept up there at 0. And most likely that's going to go up because it's not going to cross that horizontal asymptote. But we can check by putting in 1 point just to see. If we put in 1, we're going to get -1. 1 minus 4 is -3. So that is going to be 1/3. And so this graph is going to look like that. So here is the graph of this function. Now again, we have to look at what is the domain and the range. Well, the domain is our x values. Once again, are there any restrictions in our x values? And the answer is yes. We can't have -2 or 2. So you could say this in a couple of different ways. You could say all real numbers except and we'll just write x equals -2 and x equals 2. Okay, or you could even just say x cannot equal -2 and x cannot equal 2. Either one of those. And so then in the range, now we're looking at our y values. Okay, so our y values is the range, are the restrictions, and in this case, it's, again, yes, it is. Notice, nothing, we have that horizontal asymptote at y equals -1. Nothing is between that and where our blue graph starts. So we're going to have to break this up into 2 different parts. And I'm going to say that y has to be greater than or equal to 0, because that's this top parabola-looking part that opens up. And it can be 0, but now it's also going to be y is less than -1. Okay, because if you look at that, then it's everything below that, and it goes down forever. So those are the domain and the ranges of those problems. The next thing we're going to look at is example 3, which is graph of rational functions once again. But now if we look at here, the degree in the numerator is now going to be bigger than the degree in the denominator. Once again, we're going to go through our 3 steps. Set the numerator equal to 0. X squared minus 2x plus 1 equals 0. Well, we're going to factor that. X and x, 1 and 1, minus and minus, so x equals 1. There is our 0. Now remember, that is a repeated solution, which means our graph is not going to cross there. It's going to bounce. It's going to touch it, turn around, and go a different direction. Second part, set the denominator equal to 0. We're looking for our vertical asymptotes. Well, that's an easy one. X plus 2 equals 0. We're going to get x equals -2. That is our vertical asymptote. Look at the degrees. Here we have degree of 2. Here we have a degree of 1. 2 is bigger than 1, which means there are no horizontal asymptotes in this problem. So now all we have to do is go ahead and plug in some points. So if we do that, we are going to put in a few points here. If we put in -1, that's going to give us 1 plus 1 plus 1 over 3. So 3 over 3, which is 1. Scratch that. Forgot to multiply by my 2, so it's 1 times, if I put in 1, that's going to be a -2. So that's going to be 0, which is our intercept. So let's put in 0. We're going to get 1/2. So at 0, we get 1/2. If we put in -1, that's going to give us 1 plus 2 plus 1 over 1. So that's going to give us 4. So -1, 4. And we can see that that's going to go up and go to that vertical asymptote. Now at 2, when we put in 2, we should expect that it's going to go back up. Because remember, we said it's not going to touch, or it's not going to cross at 1. It's going to touch it and bounce. So let's put in 2. So that's going to be 4 minus 4 plus 1 over 4. So that's going to be 1/4. So if I put in 2, you get a 1/4, and it's going to gradually start going back up. So our graph is going to look like that. And now, once again, if they did ask us for the domain and the range here, and they don't in this case, but the domain would be x has to be greater than -2, and the range would have to be y is greater than or equal to 0. All right, so those are the 3 types of problems that we're going to be looking at on our assignment. I'll go ahead and do these 4 examples in the guided practice. You can go ahead and do those and then pause the video, and then you can hit play when you are ready to resume. And here are your graphs to the guided practice questions. So if we look at number 1, notice numerator in the degree in the numerator is smaller, horizontal asymptote 0. Number 2, degrees are the same. Still the horizontal asymptote is the division of their leading coefficients, which is 3. They're the same again in example 3, so the leading coefficient is 1 in each, so then the horizontal asymptote is y equals 1. And the degree in the numerator is bigger in example 4, so there is no horizontal asymptote. So if we look at these problems, then we just plug in. It's all about plugging in points. Once you've found those 3 things, it's all about plugging in points. Now, before we finish talking about this, I want to go back to that last example. Notice I have the graph on the right side of that. I forgot to put on the graph on the left side. So when we put in those points on the left, we're going to get another branch of this, but it's going to be down here off the graph. And so it's going to look like that, just like example 4 in the guided practice here. Okay, which in this case is going to make it difficult to find the domain and the range unless we know what exactly those values are. But in this case, we would say that the domain is going to be all real numbers except for 4, so that's not the hard one. But the range, then, we would say we'd have to find whatever this highest point is here and whatever this lowest point is here. So in this case, for example 4, let's say that the domain, or that the range, the y value is 1.7. So it would be y is less than or equal to 1.7. And in this one, if it was like 15, then it'd be y is greater than or equal to 15. So remember, basically when we talk about section 8.3, we're graphing general rational functions. The 3 steps we're going to look for is this. We're going to set the numerator equal to 0. That's going to give us our x-intercepts. We're going to set the denominator equal to 0. That's going to give us our vertical asymptotes. And then we're going to look at those degrees. If the degrees in the numerator is smaller than the degree in the denominator, then we're going to have a horizontal asymptote at y equals 0. If they're the same, then we're going to divide those leading coefficients. If the degree in the denominator is, if the degree in the numerator is bigger, then there is no horizontal asymptote. So here is, or that's what section 8.3 is about on graphing general rational functions.